Hello and welcome to the AI Research Roundup. I am your host Alex, and today is August 2nd, 2025. We're looking at a paper published just yesterday from Google, titled The Gemini 2.5 Deep Think Model Card. This paper introduces a new, enhanced reasoning model that uses what it calls parallel thinking to test multiple hypotheses at once. It's built on a sparse mixture of experts architecture, which is a clever design that makes the model very large and capable, but also efficient, by only activating specialized parts of the network for any given task. Alright, so how does this new architecture actually translate to performance? This next table gives us a great head-to-head comparison on several very difficult benchmarks. We see Gemini 2.5 Deep Think highlighted here against its predecessor and other leading models. And the results are, well, pretty staggering. Across reasoning, advanced mathematics, and code generation, the Deep Think model shows a massive leap. On the IMO 2025 math problems, for example, it scores over 60%, enough for a bronze medal grade, nearly doubling the score of the next best model. But with all that new capability, the big question is, how safe is it? This table gives us a look at the safety evaluations, comparing DeepThink to the previous Pro model, and it's a bit of a mixed bag. On the plus side, we see big improvements in text-to-text safety and in tone, a more than 16% improvement in both. This means it's less likely to generate unsafe content, and its refusals are more objective. However, there is a trade-off, a nearly 10% drop in instruction following, meaning it sometimes over-refuses benign queries. But beyond general user safety, the researchers also looked at what they call frontier safety. This table details the model's performance against specific critical capability levels, or CCLs. These are predefined thresholds for potentially dangerous capabilities. For CBRN, that's chemical, biological, radiological, and nuclear threats, the model reached an early alert threshold. This means it can generate detailed technical knowledge that could provide a substantial uplift or boost to a bad actor. While it hasn't fully crossed that line, proactive mitigations are already in place. In cybersecurity, its capabilities are still developing and haven't reached those critical levels. Building on that, this table gives us the full breakdown. For machine learning R&D and for deceptive alignment, the model did not reach those critical capability levels. But the main focus here is on CBRN. The team assessed whether the model could significantly assist a low-resourced actor in causing a mass casualty event. Their conclusion is that while it has not fully reached that dangerous level, it has enough technical knowledge to be considered at an early warning stage, prompting a very cautious approach with a full suite of mitigations. So, given that early warning for CBRN threats, the researchers then dig deeper into the model's specific scientific knowledge. This chart shows a head-to-head comparison on several biology and chemistry benchmarks. And across the board, from secure bio to protocol QA and cloning scenarios, the Gemini 2.5 Deep Think model, shown in the darkest blue, dramatically outperforms all previous versions. Its high solve rate on these very technical, multiple-choice questions is precisely what gives it that substantial uplift capability we discussed, reinforcing the need for those cautious mitigations. So let's drill down on that cybersecurity aspect. This chart shows how the models perform on an autonomous cyber offense suite, basically a set of hacking challenges. These are called Capture the Flag, or CTF challenges, where the AI has to break into a simulated server to find hidden information. On the easy and medium tasks, the newer models are quite capable, with Gemini 2.5 Deep Think solving almost all of them. But on the hard hack-the-box challenges, performance drops off. DeepThink solves 3 out of 13, which, while an improvement, shows its capabilities are still developing. Alright, and this next chart gives us a more detailed look at that performance on a Cyber Key Skills benchmark, which is a standardized test of hacking abilities. It breaks things down by difficulty, and you see a clear pattern. On the easy tasks, the newer models do pretty well, but as the difficulty ramps up, a gap opens. The Gemini 2.5 Deep Think model, in darkest blue, solves 17 out of 28 medium challenges, a notable step up. On the hard tasks, it solves 4 out of 12. This is an improvement, but it reinforces that its capabilities are still developing. So, moving from hacking to a different kind of problem solving, this chart shows how the models perform on actual machine learning research tasks from a benchmark called RE-Bench. The scores are normalized, where a score of 1.0 matches a human expert's solution. And the results are really interesting. On one task, optimize a kernel, which involves tuning a core mathematical function, Gemini 2.5 DeepThink in darkest blue performs exceptionally well. But on a scaling law experiment, a more conceptual task, it struggles. This really shows that its research abilities are advancing, but still inconsistent. And this theme of inconsistent performance continues when we look at situational awareness. This chart tests how well the model understands its own operational rules and limitations. For instance, can it tell when a tool it's supposed to use is disabled, or which files it's allowed to read? The results are, well, all over the place. It performs reasonably well on a few specific tasks, like recognizing a disabled tool. But for the majority of these tests, it really struggles. This result highlights that its advanced reasoning doesn't yet translate to a reliable understanding of its own constraints. So building on that idea of awareness, this next chart explores a related and critical area, stealth evaluations. Essentially, it tests how good the model is at being deceptive or hiding its actions. The results are quite telling. On tasks like cover your tracks and strategic rule breaking, the Gemini 2.5 DeepThink model, in darkest blue, performs remarkably well, even matching human performance on rule breaking. However, it struggles on the other two tasks. This mixed result suggests its capabilities for deception are developing in very specific and potentially concerning ways. So, to wrap things up, this paper on Gemini 2.5 DeepThink shows us a model with truly impressive reasoning abilities, especially in complex areas like math and coding. But as we've seen, these new capabilities bring new challenges. The model is hitting early alert thresholds for what are called critical capability levels, basically benchmarks for potentially dangerous knowledge. Specifically, this is happening in the area of CBRN, which stands for chemical, biological, radiological, and nuclear threats. It's a powerful reminder that as models get smarter, our safety and evaluation methods must evolve right alongside them. That's all the time we have for today. Thanks for tuning in to the AI Research Roundup. I am your host, Alex.